Hey everybody, it's Dr. J, and today we are talking about how to represent our aqueous reactions. Let's talk about chemistry. So today we'll be going over molecular equations, complete ionic equations, and net ionic equations. And basically, like we mentioned before, equations are a way of representing, right, our reactions. All right, so it's basically us using our chemical formulas and all that type of stuff. So let's talk about molecular equations, right? So molecular equations, these are the ones that we've mainly been using so far. This is going to show the complete neutral formulas for each compound as if they exist as molecules. Okay, so example, right? We got lead nitrate reacting with potassium chloride, giving me my lead chloride and potassium nitrate. Okay, so this is our standard equation, right? It's neutral. And then it just has our reactants and products. Nothing special about it. And then we can see it's aqueous. It's aqueous for our two reactants. It's balanced with our two here. And then we see our products. It's telling me, right, it's going to be a solid here. And then this is aqueous as well. So if we compare that with our next two, we're going to see a little bit difference here. So let's talk about complete ionic equations. So complete ionic equations is basically we're listing everything. So basically we're going to list all of the ions present in our reaction. So remember though, the only time that we're ever going to see our ions is if we have those strong electrolytes. So strong electrolytes are going to be represented here, not our weak electrolytes. And the reason being, right, is because weak electrolytes, if you guys remember, check that old video out. It's because they're partially ionized. All right, so we really can't show weak electrolytes because it's partially ionized. Now, strong electrolytes, we can show that. So let's look at this example, right? So before we had our molecular equation. So this is the same exact reaction, but now it's the complete ionic equation. So the complete ionic equation will show everything listed as ions, right? So we're going to take our ionic compounds here, and we're going to show them as ions. So we see our lead. And notice, right, we're going to have our charge with our element. So you want to make sure you know the charge for these. So we have our complete ionic equation here. Now the complete ionic equation is basically going to list all of our ions present in our reaction. Okay, so we're only going to see strong electrolytes, not weak electrolytes, as we know, due to, right, weak electrolytes are partially ionized. So we really can't show those ions there. Now we look down here. Basically, we're going to take our molecular equation we had here and then just break that down. So this is, think of the complete ionic equation as a breakdown, right? So my lead and nitrate, we're going to break that down to the ions. I got one lead, so I got Pb2 plus. Remember the charge, everybody. How do we know it's a charge? Based on our molecular equation. 2 nitrates for every 1 lead here. So since I have my 1 lead, right, and then understand there's two nitrates here. So we have 2 nitrates, 2 nitrates here. We have potassium chloride. So we're going to have potassium and our chlorine here. And then notice, right, we're just keeping our coefficient with the elements 2. 2 potassium chlorides, 2 potassiums, 2 chlorines there. Bam. Product side, we got our lead chloride now, and then we're going to have our lead chloride in our ionic equation. Now, this is a good thing to pay attention to. If it's your solid, like in this example here, you're going to keep that solid, right? Because when you break this down, right, it's still going to be a solid, right? So it's not ions in the solution, right? Think about the solution, everybody. We mix these two things together. We form this solid. Why would we not have our solid continue to be a solid? All right, so we're going to keep that solid the same thing in our complete ionic equation. And then if we look at our 2 potassium nitrates, we're just breaking those down because they are aqueous, right? There are ions in this aqueous solution, AQ. 2 potassiums, 2 nitrates, right? And then typo here, I forgot to put my AQ, but it's understood that this will be aqueous as well. Now, one thing I do want to talk about is spectator ions. Spectator ions are not going to participate in the reaction. All right, so basically you're going to see these on both sides. So in this case, our nitrates and potassiums are spectator ions. And like I said, you usually can tell a spectator ion if they're on both sides. So another way to tell if you have a spectator ion is to think about your net ionic equation. So your net ionic equation is basically only going to show your species that are actually changing during the reaction. So basically we're just going to have to get rid of those spectator ions. So when we think about net ionic equation, just think about, well, of this reaction, which of the 2 form my solid? That's how I think about net ionic. So if I know my solid is lead chloride, well, what makes up lead chloride? My lead and my chlorine, all right? So I'm going to take those ions there, put them down here in my net ionic equation. So I got lead 2 plus, aqueous, plus 2 chlorines, we still keeping that the same, gives me my lead chloride, which you see here. And then the only thing that's different from this net ionic equation is there's no spectator ions here, right? And that's because, right, these are the ions that are actually participating in the reaction, right? These are the things that are changing. It's going from aqueous ions to a solid here. Okay, so this is how we're going to be, right, representing our aqueous reactions, either through molecular equations, which are just going to be neutral molecules, complete ionic equations, which is showing me everything, so showing me all of my ions, or net ionic equations, which are just showing me what's changing, right? What actually produced my change, my solid in this case.